Hey guys, welcome back to another Katona's tutoring video with your host, Mr. Katona. Today we're going to go over a topic that can confuse a lot of high school chemistry students when you first learn the topic, dimensional analysis. Now, you're probably using this in physics if you're watching this video, you're using this in chem, maybe in 8th grade you're learning a little bit about it, or you could be in college learning about dimensional analysis again. Dimensional analysis at first can be tricky, but if you understand a couple of the tricks and the idea behind it, it can actually be pretty simple. So without further ado, let's get started. So with dimensional analysis, this is just a fancy way of converting from one unit to the next. What that means is I have one value and I want to convert it to another value. I have liters and I want milliliters. I have days, but I want years, or vice versa. The way to do dimensional analysis is pretty simple. If you look at my setup up here, my equation, you're going to take the known value with the known unit, and you're going to multiply it by a conversion factor. The conversion factor is a fraction that relates the current unit to the new unit. Notice my current unit is on the bottom. Your conversion factor, because it's a fraction equal to 1, can be flipped either way. But you always want the current unit on the bottom so we can cross cancel. So let's look at an example problem. In this example problem, I want to know how many seconds there are in 5 minutes. So what I'm going to do is I'm going to take my 5 minutes, my known value, and I'm going to multiply it by a conversion factor. This conversion factor is going to relate minutes to seconds. So I know that 1 minute is 60 seconds. Now notice, like I said, the current value, minute, has to be on the bottom. My units must cancel. So my minutes cancels out with minutes, and I'm left with seconds, which is what I want. Now, all I'm going to do is multiply straight across. 5 minutes times 60 seconds, which would be 300 seconds. So there are 300 seconds in 5 minutes. Done. Solved. Now I know my unit. So that's essentially the simple part of the dimensional analysis, where we only have to convert with one conversion factor. Sometimes you're going to have to use multiple conversion factors because you have to travel across multiple units. For instance, in example 2, we start with 3 hours, and we want to know how many seconds are in 3 hours. So there are going to be 2 conversion factors that I use here. So let's start. I have I've got 3 hours. Wow, it's not responding today. Three hours is my starting unit. I'm going to multiply that by the first conversion factor, which is going to be relating hours to minutes. So I know there's 1 hour with 60 minutes. Now again, notice how I have hours and hours, so they cancel. But now I'm going to minutes. I don't want minutes, I want seconds. So now I have to use my second conversion factor, which would be 1 minute is 60 seconds. So now I'm going from hours to seconds. I'm good. So my hours cancel out, my minutes cancel out, and now I'm going to be left with seconds. Now I multiply straight across, and obviously I would divide by the denominator, but in this case they're both 1, so it's not going to change my answer. So I'm going to first start with 3 times 60, get 180, then multiply again by 60 to get 10,800 seconds. And that's how we would take care of that. Notice I let my units tell me what conversion factor is going to go first. Because I start with hours, I need to get hours to minutes first to then get from minutes to seconds. This way, it's very easy to follow. I just multiply. And again, to reiterate, if I have a number other than 1 in the denominator, when I multiply the first, I'll then divide by that denominator. Then multiply again, and then divide by that denominator. But because they're both 1, I didn't have to do any division. Now, this next problem uses a couple more. It's a little bit more in depth. So let's look at what we're given. We're given 3 days, and we want seconds. So now we're going to use a couple conversion factors here. So I'm obviously going to start with my known value of 3 days, and I'm going to multiply that by my first conversion factor, which would be 1 day is 24 hours. Then my next conversion factor we already used up there. There are 60 minutes in 1 hour. Then we want seconds, so then we have to again convert. We have to take 1 minute is 60 seconds. So now I go from days to hours, from hours to minutes, from minutes to seconds. Let's make sure we can cross cancel. Day, day, hour, hour, minute, minute. We're left with seconds. Perfect. Now again, our denominators are all 1 in this case, so we don't have to do any division. Instead, we're just going to multiply. 3 times 24 times 60 times 60. And we get, in 3 days, there are 259,200 seconds. Voila. Easy peasy. Now, there's a couple more problems that we're going to do, and they're using the metric system. So for easy response, I put our metric system chart up here so we know. Obviously, the 1-to-1 is just the regular, whether it's a gram or a liter or whatever. That's our regular unit. And then we have hecto, kilo, mega, giga. And then below that, we would have centi, milli, micro, nano. Now, in this problem, it wants us to go from 2.5 kilograms to grams. So we're going to do the same thing like we've been doing. We're going to put our current value of 2.5 kilograms, and we are going to convert that to grams. So we have to find a conversion factor that relates kilograms to grams. So I know they're going to be 1,000 grams in 1 kilogram, right? Because kilo is 10 to the 3, which would just be 1,000, 1,000. Right? Because 10 to the 2 would be 100, 10 to the 3rd would be 1,000. So I know 1 kilogram is 1,000 grams. Also keep in mind, when we're going from a big unit to a small unit, that number should be bigger. If we're going from a small unit to a big unit, that number should be smaller. Because remember, this is a conversion factor. We are converting our current value to a value that is the same but in a different unit. So obviously, if my kilograms are here, then I should have a lot more technically with grams because there are more kilograms, or there's more grams in a kilogram. Hopefully that makes sense, but that's just like a number sense. Obviously, if I have a bigger unit, when I convert to my smaller unit, I'm going to have a bigger number because they have to equal each other. It's not like I'm adding anything or making anything bigger or smaller. I'm just simply converting from one unit to the next. But that's just a way to make sure you're doing it right. Now, 2.5 kilograms times 1,000 grams over 1 kilogram. So kgs cancel. Now I'm left with grams. Now all I'm going to do is multiply. 2.5 times 1,000. That's going to give me 2,500 grams, which makes sense. There are going to be a bigger number for grams than kilograms if they're like the same value. Now, just like with our previous problems, we can end up having to go from centi to kilo or from milli to mega. And that's where the easiest way to do that, what I tell my kids, is you want to go from the known value to your middle value, from the middle value to your other value, because all of them are related to the gram or the liter or your simple factor. So let's check the next problem. Again, I gave us a chart, and now I want to go from liters to milliliters. So keep in mind, liters are bigger than milliliters, so let's see what happens. I'm going to start with my known value, 783 liters, and I'm going to set up a conversion factor that relates liters to milliliters. So let's look here. I know I'm going to have liter on the bottom, and I'm going to have milliliters up top. Now, milli is 10 to the negative 3. So if we think about it, 1 kilogram is 1,000 grams. Now, because we're going smaller, 1 gram would be 1,000 milligrams, or 1 liter is 1,000 milliliters. So we're going to have 1 liter on the bottom is 1,000 milliliters up top, because there are 1,000 milliliters in 1 liter because we're going down. That's why this chart is so helpful. Now all we're going to do, again, is multiply. I'm realizing none of my problems are set up for division, so if you want to see a separate video showing you how to divide, let me know in the comment section. But if this helped, then that's great. So 0.783 times 1,000 would be 783 milliliters. And that makes sense, actually, because if I multiply by 1,000, I would move the decimal once, twice, 3 times. It would be 783 milliliters. I think I have one last problem. Look at that. We have one last problem. This is what I was talking about earlier. We're going to go from kilograms to milligrams. So what I'm going to do is I'm going to set this up. I'm going to start with my known value of 0.75 kilograms, and I'm going to multiply by my first conversion factor. I know 1 kilogram is 1,000 grams. I'm then going to multiply, get grams on the bottom, milligrams on top. On the bottom, because I'm going to have 1,000 milligrams in 1 gram, I'm going to have 1 gram on the bottom, 1,000 milligrams up top. So now, again, there's no division. So like I said, if you want to see how to do the division aspect, if you want to see dimensional analysis but set up the opposite way, I could totally do that. But That's up to you. Please leave a comment down below if you want to see that. We're going to multiply 0.75 times 1,000, then times another 1,000, and there are 750,000 milligrams in a gram. In a kilogram. Which makes sense, right? Because if 1,000 grams would be here, then that's another 1,000, so we should be moving 6 decimal places, which is what we did. 1, 2, 3, 4, 5, 6. Scientific notation. Anyway, hopefully this helped. This should have given you a nice little setup, a nice little roadmap on how to do dimensional analysis. This is probably the easiest way to start with dimensional analysis, and as you get more with it, you can kind of cheat some steps, but this is how I would do it if I was a beginner. With that being said, like I said already, if you want to see a video that talks about how to do dimensional analysis, but with the opposite way, where we're going to have ones on the top and some bigger numbers on the bottom where we would have to divide, please let me know. Or I could set up problems where you'd have to do both. Just let me know. If there's another topic you would like to see, please leave a comment below and I can make a video on that. Also, if you liked the video, please leave a like. If the video helped you in any way, please leave a like. If you're new to the channel, please subscribe. And please tell your friends, tell friends of friends. Let's get this channel out there so that I can help as many people as I can. I'm going to make videos all the time. If you have ideas you want me to do, please leave a comment below. And with that being said, have a great day, happy holidays, and stay blessed.